Presenting author is Yoshihiro Sato. He received ME in Computer Science Engineering from Tokyo City University in 2018. He is currently a PhD student at Tokyo City University.
Thank you, Chairman. Hello, everyone. I'm Yoshihiro Sato from Tokyo City University. The title of my presentation is Aerial, Floating, and Naked Isolated Display using Cross Mirror Array. The presentation flow is as shown. The first is introduction. In recent years, due to the impact of the new COVID-19, infection control important in public space. As an example of infection control, we have been wearing a mask and alcohol disinfection and avoiding direct opportunity with other in online meeting. Connect opportunity include not only face-to-face meeting with other, but also touch object with specific people. For example, a touch panel of ATM and elevator button and etc. In ATM touch panel, in order to reduce the use cash, a cashless system as contactless payment has been introduced. For example, a QR code payment system. Elevator button, same elevator are equipped which two speaks which are disabled and can use to press button. As a more realistic system method than a two speak, there are also elevator button that is touchless display. As solution this problem, the use of non-contact or a touchless panel is expected. This panel can be controlled by moving your finger in air. Therefore, avoid contact and infection control. The picture is an example for use touchless panel. The touchless panel is compared of the two technologies. Display technology for a display screen in air and sensor technology for controlling by touchless. In this study, we focus on this display technology, this one. I explain the previous study on aerial display. The first previous method is aerial display method using cross mirror array. In this method, the surface of the thin glass are mirrored. The glass is then placed in a row to create a mirror array. Finally, the mirror array is arranged so that they are orthogonal. This one. In the way, the display or object are formed in the plane symmetric position in the respect of cross mirror array, thus creating an aerial display or image. The second previous method is integral photography method. In this method, object is captured through two-dimensional lens array. The observing the capture image through two-dimensional lens array light rays are reproduced. The method display in the object in the air by reproduce in the light ray. In structure diagram from the image, the image at the far side in the captured image. In the center is two-dimensional lens array. The front side is a reproduced object. There is also flat panel method, which in extent of integral photography and can be observed from a 360 degrees. There is however a problem with the study we have present. For example, in the first previous method is the problem is the display appear flat flat and cannot three-dimensional. In the second method, problem is it can be observed from a 360 degree, but the resolution is low. The low resolution is not suitable for text display. Therefore, the purpose of this study is to construct a high resolution and stereoscopic aerial display that can be used for interface. Second content is method. In order to give the observer in scene of three-dimensionality, it's necessary to provide binocular parallax. Binocular parallax is a technique that provides a 3D-dimensional effect. By providing a difference point of view to a left eye and the right eye. Binocular parallax method includes the parallax barrier method and the lenticular lens method and etc. For example, the illustration shows the lenticular lens method. Each color on the display in focus. Each color on the display focus on difference position by passing through the lenticular lens. Thereby, the observer can observe difference image with the left eye and right eye. The type of display are called a naked eye 3D display. The aerial display technique is possible using a cross-mirror array in order to give 3D effect to the aerial display. If the image displayed in the air a difference for the left eye and right eye, and depending on the observation position, a stereoscopic vision is possible. The display system proposed in this study is as follows. A naked 3D display is by observer from the certain distance from the display. A multiple image can be observed. A cross-mirror array is image displayed at the specific position and display and in the air at the position with plane symmetry. This combined result in a stereoscopic disparity image that can be observed. Experiment device proposal system in a suspect. In the observation experiments, image with different background color are displayed in order to confirm that different images are being observed. The parallax image to be displayed is generated from 4 images. The second observation experiment, we display character of difference size and check whether that character could be read on the image display in the air. Result. In the proposed method, image with different background were confirmed. The right figure show the result observation using stereo camera with distance of 65 millimeters between cameras. It was confirmed that a different background image was transferred to each of stereo camera. In result of the second observation experiment, the left image is the characteristic image shown on the 3D display. And the right image shows the character display in the air. The numbers show are millimeters as the size of characters. The size of character display in the air are about 1/6 those shown the display. Discuss. In the experiment system we constructed, it was confirmed that a different image could be observed depending on the observer's position. The switch of the image was at the interval of 65 millimeters, which is same distance as the average distance of between the human eyes. Therefore, a stereoscopic possible with the image of naked 3D displayed by crossed mirror array. The resolution of the display used in the experiment is 4000. In lenticular lens method, the lens are one-dimensional rods, so the image character is a response to horizon movement. The number of horizon pixels that disparity image can be used reduced. In the case of the display for a disparity image, the resolution at which one parallax can be used will be 540 3084 840. A conventional aerial display resolution have been reported to be 320 and 200. In the case, a character similar than a 7 millimeter display in the air, the character blur with the surround white pixel and could not be read correctly. It was confirmed that a legible character could be displayed as long as they are 11 millimeters or larger. The three-dimensional image that you can actually observe with blur. There are two possible causes for the blur. The first is the distance between the display and the cross mirror are too far. The second is lack to pressure of the cross mirror array, which diffuse the light and reduce and resolution. Transmission of the cross mirror array using in the experiment 50%. Conclusion. In this study, we propose a system for a display a disparity image in the air based on the structure of naked 3D display. For the experiment result, 4 parallax are displayed, and it was confirmed that each could be observed in air. The image displayed in air were blurred, therefore it is though that is necessary to increase that resolution. At the end of my presentation, thank you for attention.